Have you ever wondered why the same side of the moon always faces us? Or why the ocean tides rise and fall twice a day? It all comes down to a gravitational dance between the Earth and the moon. Let's take a step back and gaze at our celestial partner, the moon. It's not just sitting there idly, oh no, it's constantly exerting its gravitational pull on our planet, and that pull is most potent on the side of the Earth that's directly facing the moon. This pull is so powerful that it coaxes the water on our planet to bulge out towards the moon, creating what we call a high tide. But what about the other side of the Earth, the side that's turned away from the moon? Here's where things get interesting. There's another bulge of water on that side too, but how can that be, you may ask? The answer lies in the centrifugal force caused by the Earth-Moon system's rotation. This force pushes the water outwards, away from the moon, resulting in a second high tide on the opposite side of the Earth. Now think of the Earth spinning on its axis like a top. As it does so, different locations on our planet pass through these two bulges of water. This journey through the bulges is what gives us two high tides and two low tides roughly every 24 hours. Imagine standing on a beach watching the waves come in. You're not just witnessing the ceaseless rhythm of the sea, you're seeing the result of a cosmic ballet, choreographed by the forces of gravity, performed by the Earth and the Moon. So, in essence, the ebb and flow of the ocean tides are the result of the Moon's gravitational pull and the Earth's rotation. This cosmic dance, this gravitational tango, is a fundamental part of life on Earth, and it's happening every moment of every day, whether we notice it or not. While the Moon is the primary conductor of this tidal symphony, the Sun also plays a significant role. Imagine the Sun as a supporting musician in our cosmic orchestra, contributing its own gravitational pull to the Moon's lead. This celestial duet results in the phenomenon we experience as ocean tides on Earth. The Sun's gravitational force, although less than the Moon's due to its greater distance from Earth, still has a substantial impact on our tides. Think of the Sun's role as a subtle enhancer, adding depth to the tidal music. When the Sun, Earth and Moon align during full moons and new moons, the Sun's gravitational pull aligns with the Moon's. This alignment enhances the tidal ranges, leading to higher high tides and lower low tides. These are known as spring tides, not because they occur in the spring season, but because the tide springs forth with greater energy. Now contrast this with the times when the Moon is at a right angle to the Earth and Sun. This happens during the first and third quarters of the lunar month. In this setup, the gravitational pulls of the Sun and Moon partially cancel each other out. Consequently, the tides are less dramatic and we experience weaker high and low tides. These are known as nap tides, derived from an Old English word nep, meaning without the power. It's fascinating how the interplay of gravitational forces from the Sun and Moon, coupled with the Earth's rotation, choreographs the ebb and flow of the ocean's tides. This natural rhythm is not just a spectacle for us to admire, but an essential mechanism that affects marine life, influences climate, and even shapes our coastlines. Thus, the Sun and the Moon together orchestrate the rhythm of the ocean tides. This cosmic ballet of celestial bodies, their gravitational pulls, and Earth's rotation creates a symphony of tides that is both complex and captivating. It's a rhythmic dance that has been performed for billions of years and will continue for billions more. Now that we've understood the basics, let's delve into some lesser-known facts and stories associated with tides. It's astounding how much influence the Moon has on our planet. And it's not just about the oceans. Firstly, did you know that the Moon is in a gravitational clinch with the Earth? This celestial dance has led to what we call a tidal lock. This means that the same side of the Moon is always facing our planet. It's like the Moon has one face, a permanent profile that it presents to us. This is why we only see one side of the Moon from Earth. It's not that the Moon doesn't rotate, it's just that its rotation is in sync with its orbit around the Earth. Now let's talk about Earth tides. Yes, you heard that right, Earth tides. It's not just the oceans that respond to the Moon's gravitational pull. Our solid Earth does too, albeit subtly. The Earth's crust experiences a slight rise and fall due to the tidal forces known as Earth tides. It's a tiny effect, but it's there, a testament to the far-reaching influence of the Moon's gravitational pull. Finally, let's explore the potential of tidal energy. The constant ebb and flow of the tides carry an immense amount of kinetic energy. Researchers are exploring ways to harness this renewable resource. Imagine power plants generating electricity from the rise and fall of ocean tides. It's an exciting field of study, and while there are challenges to overcome, the potential benefits are enormous. So, from influencing our view of the moon to potentially becoming a source of clean energy, the tidal forces exerted by the moon have a far-reaching impact beyond the rise and fall of ocean tides.